Okay, stop being bored and start doing something useful. Look, you can make yourself a CNC machine controlling pendant, a bit like this thing, what I made, and it's dead easy. It's got a schematic a bit like this. Look at this exquisitely complicated circuit diagram. God, look, it's got buttons. That's all it takes is a bunch of buttons and an Arduino Pro Micro. You get that, you connect it together, you run the program that I'm going to show you, and you've got a CNC machine controller. Wow, let's get on with it. Okay, if you're going to use the Arduino Pro Micro to do development, you probably want to install the drivers and the part of the Arduino environment that understands what your board is, in which case you need to go to this address here, sparkfun.com, tutorials Pro Micro FIO v3 hookup guide /all, and come down to this button here to install the drivers. Click on it. Then you need to see this dialog here, and it prompts you to download and save the zip file of the Arduino board's master archive on your computer to somewhere that you will know where it is, because you're going to have to unzip this file, and then once you have that unzipped, you will need to go to that folder, and when you connect the board to your computer, when you plug the Arduino into your computer the first time to start using it, Windows will prompt you and say it doesn't have any drivers, where are they? So you then need to navigate to those folders. I think I have them installed on somewhere like on my C drive, which would be something like somewhere like here. So I keep mine in an install folder, you see, and in there, so you download the zip archive, and then you end up with a folder structure like this, and you would go to SparkFun, you would go to AVR, because it's an AVR based board, and then you go to signed driver. Now this is the place that you point Windows to when it asks you where the heck the drivers are for your Arduino Pro Micro, to this place here. Okay, so make a note of that. Now after you've downloaded that zip archive and stuck it on your drive, you probably also want to set up Arduino framework, this thing, so that it understands the SparkFun boards. And to do that, what you want to do is to go further down this page to the part where it talks about installing the Arduino add-on. You see from this scroll bar here that we're part way down the page, and all you need to do is to copy this link to GitHub, the SparkFun Arduino boards package manager. You copy that, you go into Arduino, go to preferences, and down here the additional boards manager URLs, you click on that window there, and if this is blank you just paste that straight in there, or if like here you've got something else in there already, well, this is already in there, you see there's the SparkFun stuff there. If that was something else, you would go to the end, you would press enter to give you a new line, and then you would paste it on a fresh line of its own, because you can have many different types of development boards connected in your Arduino IDE. Okay, so there you go. That's how you would set up the Arduino IDE and put drivers on your machine for the Arduino Pro Micro. Once you've done that, then you can do development with the board, and that's what I've been doing with my CNC pendant project. Okay, so let's have a look at the Arduino program. This is the Arduino Sketch, which performs the CNC pendant functionality. It's written for SparkFun Pro Micro, an Arduino Pro Micro. This is actually running on a cheap clone that costs less than a fiver. That, and with a few buttons, the whole thing can't have cost more than about £6 sterling to make, in terms of the actual electronics parts and some circuit board I had lying about. Okay, let's move on. First of all, this Sketch uses the keyboard functionality, because when you connect it to a PC, it looks like a keyboard as far as the PC is concerned after it's been recognized as an Arduino. So we need to have the include statement for the keyboard.h library. Once that's been done, we define some names for the pins that we're going to use for convenience. So for example, on the circuit diagram I showed earlier, pin 2 was connected to the stop button, and so I've called it stop button for convenience, so the code is easier to read. I do that for each of the buttons that I'm going to be using. I have 7 buttons. I have effectively right and left, up and down the bed of the machine, and up and down in the air. So that's the 7 functions in total. Next, down the sketch, we have the declaration of some Boolean variables. Now, when we're trying to determine what's happening to the buttons on the machine, we have to consider the state of the button at the moment and the state that the button was in last time that we inspected it. Because if we want to know if the button has just been pressed, we have to look to see whether it wasn't pressed last time and is pressed now. If that's the case, then it's a new button press, and we have to issue the command to the PC that tells it that it's a fresh button press. Similarly, if, for example, the current the last state of the button was pressed and the current state of the button is not pressed, then we know that they must have just lifted their finger off the button, so the button has been released. And so our code must issue the button released command to the PC. That is the truth table of the code. Simple as that. So we use these Booleans. So we have, for example, the Boolean for the stop button, bool stop button, and the last bool stop button. That pair of Booleans are associated with the stop button functionality. This code consists of the same thing basically 7 times in a row, once for each of the buttons, and that's about it. It's that complicated. Next up, we have the key presses that we've chosen to use in the PC software. And there is a library, the keyboard library used on the Arduino, and this page here, this is a very important page. The Arduino reference has a keyboard section for the keyboard library, and you need to search for Arduino keyboard modifiers, and then you will be able to find this table, which tells you what code to use to get these appropriate key presses. Because if you don't use that, you have to use something only the normal ASCII characters. So for example, a normal ASCII character would be, you would have to use a hash sign or a letter A or a letter B or something like that. Okay. Okay. So there you go. We will be using a combination of key presses for our pendant. We will be using the control key and the function keys. Excuse me one moment. And that will enable us to find a combination of key presses which are unique and will ensure that the CNC machine will only move when we want it to. Okay, so for example, for the stop key, we will be using the function key, function 10, and control. So on the normal PC keyboard, I'll be able to achieve exactly the same function by pressing the control key and function 10. And on the pendant that I make, I'll do a similar thing by just hitting the little red button on the pendant. So we now move on to the setup routine. That is the setup routine in its entirety. All we do is we declare the pins as inputs with pull-ups. We do that for each of the input pins, and we have to begin the keyboard functionality that tells it to start talking to the PC like a PC keyboard would, like a standard keyboard would. Excuse me. Then there is the main loop of the program. Now this loop consists of a 50 millisecond delay to make sure that it doesn't do this thing too quickly, and after that it then does the same thing for each of the keys, and there is the process for the stop key in its entirety. So you just imagine that being done for each of the 7 keys, and the process basically is like this. For each button we do exactly the same process. We set the boolean that I've already shown you to reflect whether or not the button is pressed. After we've done that, we then compare the boolean and the previous value as per this truth table, and if it's a new button press, then we send the key sequence that tells the PC it's a new button press. If it's a button release, then we send that key sequence to the PC. And after we've done one of those two things, or neither, if it's neither of those two scenarios, then we store the state of the boolean in the variable called last boolean. That concludes the process that we do, and we do that for each of the keys that we're running code for. So here's the actual code itself. This is for the stop key. If digital read of the stop button equals low, remember in C, Arduino C as well, it's a double equal sign, so it's equals low. That is your check to see if the pin is low. If the pin is low, then you set the boolean to true, which says that the button is being pressed. So the boolean stop button is true because the button's pressed. Otherwise it's false. You mustn't forget to set it to false if you're not pressing the button. If it meets the condition such that it's true now and it was false before, then it's a new key press. So you issue the commands to the PC that tells it it's a new key press. And in that scenario, I've decided that I want it to be the control key and the stop key. Now the stop key was defined back here as being F10. So if I need to change this at some point in the future, I don't have to come down and edit my code. I just change the character definitions up here. That's why it's done this way. Okay. So there we go. there is the key press. Notice there's a key press command, or function rather, for pressing a key, and we press the control key and the stop key together when the press action is detected, and we use the release function when we detect the button has been released. And at the end we copy the state of the button into the last boolean, the boolean that keeps the previous, the boolean called last. And that way when we run this, when we come around the loop next time, the variable called last boolean will tell us the state of the key the last time we were in the loop. I'm not very good at explaining things, am I? Finally, here we are. If, for example, I didn't want to just use the function keys and control keys, and I wanted it to be the letter Y, for example, on the keyboard, I would literally just put single quotes Y, close single quotes. Rather than that stop key thing there, it would say that. So here we go down, and you see I do the same for the Z minus button all the way through. And at the end of it, I finish the loop. That is the entire program. That's its entire functionality. That is the end of the sketch that runs on the Arduino. You connect that to your PC, and then in the UGS software, Universal G-Code Sender software, you configure it, its keyboard shortcuts to interpret these keyboard sequences as being the motion control commands that you require. And I'll hopefully show that next. So to use the pendant with your software, you need to run your software. I'm using the Universal G-Code Sender, and that is the thing I can demonstrate it with. Universal G-Code Sender has a Tools menu, and below Tools is Options, and within Options is the key map. And that enables me to set up the keyboard shortcuts. I'm going to delete one of my earlier experiments quickly. Okay. Now here I have already plugged the pendant into this PC. Not a lot happens. I'd already installed the drivers. You may have to navigate to the drivers as I instructed you earlier on. But I can't show you that because I've done that ages ago. But now I'm going to set up the shortcut for the X plus button. If you remember, the X plus button is the right hand button on my pendant. I'm going to edit the key press. It's now waiting for me to press the keyboard shortcut. Now I could press the control key and one of the function buttons on the actual PC keyboard, but I'm going to press the right hand button on the pendant now. And it recognised it as being the control key and F8. And that's all I'm going to do. I'm going to click away from that now. And that now recognises the pendant button that I want to be X plus as being X plus. I've successfully set up that button. I'm going to do the same for X minus now. There's X minus. I'm going to need to click on that. I want to edit. Try that again. Edit the keystroke. Press the X left button and click away. And then I'm going to do with Y plus, do the same thing. Press the up button for Y. You should see, if you go back in my video, that these correspond to the settings that were in my code earlier on. Jog Y minus, that's the bottom in the group of 4. There we go. Then we're going to go to Z plus, That's to make the carriage, the tool move upwards. Edit. And Z minus to make it go downwards. Edit. Press the Z down button on the pendant. Finally, stop, which is down here. Most important of all is stop, because when you're jogging, and let's do this first of all before I explain. Press the stop button on the pendant. Job done. F10. Stop is very important. If you have the distance set up incorrectly over here, okay, let's do apply. Now all of these keyboard settings are now set up, and you can export these and save them, which might be worth doing. I'm not that familiar with it, but it definitely looks like it's worth experimenting with. Okay, when you're jogging, when you're connected to the Gerbil, the controller that's running Gerbil, wow, look at that, it works with a whole bunch of different firmwares. But you use this icon to connect to the board. When you're running, you can set the step size that it moves when you press the jog button with these icons. Well, you could have that set to 10 or 40, for example. So one single press of the button could make it move a lot. And it might be more than you expect, in which case you need to quickly run up here and press the stop button up here. That's why stop is on the pendant. It's a very important button. My recommendation is that when you connect the pendant, you set these settings to 0.1 millimeters for both Z and XY, and that way you send a single key press when you press the button, which moves it 0.1 of a millimeter, and then by holding your finger down, the auto repeat button that Microsoft Windows puts in for you makes the machine move many times in steps of 0.1 millimeter, which makes it move continuously, which has the effect of making a pendant move the machine continuously. So that's how I set the machine up, and then it works like you've seen in the video. That is it. Okay, something else worth mentioning is when you look in Device Manager and you have your pendant, your CNC pendant attached, you will see a couple of devices in your system. You will see an Arduino connected. Now, as it turns out, because I've had the CNC Arduino extensions installed into the IDE, it's created havoc in my system, and so this thing is enumerating as a CNC, even though it knows that it's a Arduino Pro Micro. So that probably won't happen on your system unless you play with Arduino CNCs like I was daft enough to do. However, they are a marvelous little microcontroller. Anyway, this is the other thing that happens. This is that's your HID, human interface device. That's your HID keyboard device. That is your pendant. That is how you are able to inject keyboard commands into the PC using your CNC pendant. That device will disappear in a moment when I unplug the pendant. So here goes. Unplugged it. And that is it disappearing from the system. I can no longer inject key presses into the system using my Arduino pendant-y thing because it's not plugged in anymore. So that is how it appears in your system. Okay, it's an HID keyboard device. So that is worth showing you, so you know what to look for if you're trying to work out whether or not your thing is working. Plug it in again, eh? There we go. HID keyboard device. There you go. What does it say? It says it's working properly. USB input device. Interesting, huh? I've never looked at this before. Wow. So there you go. Big fun. it's sounding whiny because it's set to 0.1 millimeter steps.